A relation is a set of ordered pairs. A relation can be written as a list or graphed. I've given an example of a list that defines a relation. Notice that there are 4 ordered pairs, and there are 4 graphs that define relations. Now, in a relation, one input can have more than one output. For example, look in the list there. 7 has got 2 outputs. In the first graph there, notice that points B and E lie above each other. They are the same output for the input of 2. In the circle, almost every x value has got 2 y values or 2 outputs as shown by the vertical line test. So the circle is an example of a relation. This cubic graph is a relation. It's a function too. Each input has only one output. And this parabola, notice again that there is more than one output for each input. The domain of a relation is all the inputs it can have, or all the x values. For example, the domain of this relation is simply a list of its x values. And notice that they are 2, 7, and 9. We don't put the 7 in twice. The range of a relation is all the outputs it can have, or all the y values. And in this case, there are 3, 11, 13, and 15. You should know how to get the domain and range of a relation from a graph. To find the domain, find the smallest x value, and then find the largest. The domain is the interval with these 2 numbers as the endpoints. So the smallest x value there is -2, the largest is 7, and so the domain is -2 to 7. To find the range, find the smallest y value on the graph, and then find the largest. Range is the interval with these 2 numbers as the endpoints. So the range on this graph is -2 to 6. Functions are a special kind of relation where only one output is allowed for each input. In other words, for every value in the domain, and those are the x values, there is a unique value in the range, the y values. The first list here is not a function because the input 7 has 2 outputs, 11 and 13. The next list is a function because each input has a unique output. For each x value, there's only one unique y value. The graph on the left is not a function. Most inputs have 2 outputs. The input 4, for example, has the outputs 2 and -2. The graph on the bottom right is a function because each input has a unique output. Here's an example from physics which shows distance traveled versus time. This graph is clearly not a function. Note that at t equals 6 seconds, there are 3 outputs. This means that the person doing the traveling is in 3 places at the same instant. I hope you can see that non-functions do not represent actual events. You may have already heard of the vertical line test for a function, and I have been using it on some of the slides already. If a vertical line intersects a graph in more than one point, then the graph does not represent a function. You can see that in graph 1, the vertical line passes through 2 points, and so it's not a function. On the second graph, I can draw a vertical line just about anywhere that intersects at 2 points, so it is not a function either. There are no vertical lines that can be drawn on graphs 3 and 4 that intersect the graph in more than one place, so they are both functions. Now, to get the domain of a radical function, remember that what's under the radical sign has to be greater or equal to 0. So let's just take the x minus 4 and set that greater or equal to 0. We'll move the 4 the other side and get that x has to be greater or equal to 4. So that's the domain. Now, for the range, in this case, we can substitute 4 into the function. Y of 4 is equal to the square root of 4 minus 4, which of course is 0. And so that's the smallest y can be, and y can take on any value above 0. So the range is y is greater or equal to 0. You could also notate it like this. 0 square bracket means that the 0 is included off to infinity. And we normally use this kind of bracket for infinity because it's not really a number. Now here's another radical. So the domain is found by setting what's under the radical sign, the 4 plus 3x, greater or equal to 0. So move the 4 the other side and get 3x is greater or equal to negative 4. And so x must be greater or equal to negative 4/3. Now we can find the range by putting that negative 4/3 into the function y of negative 4/3. And if you put that under the radical sign, you'll see that it's 0. So that's the smallest that y can be. And of course, it can go all the way off to infinity. So the range is y is greater or equal to 0. Or you could write it like this. 0. The 0 is included. That's why we use that square bracket. And we use this round bracket for infinity. It's not really a number. For a rational function, we can't have 0 in the denominator or in the bottom. So we'll set 2x minus 5 equal to 0. Find when it is 0. 2x equals 5. So x equals 5 halves. That gives us a denominator of 0. So that means that x can't be 5 halves. So we just write it like this. X is not equal to 5 halves. We can't have 3x plus 4 equal to 0, so let's set it equal to 0. And we'll move that 4 to the other side. 3x equals negative 4. Divide by 3, so x is negative 4/3. That's when it is 0, so we can't allow that. So we say that x is not equal to negative 4/3. Remember that whatever's underneath the radical sign there can't be negative. That means we have to set that 2x minus 5 must be greater or equal to 0. Now move the 5 on the other side, so I'll get 2x must be greater or equal to 5. And then just divide both sides by 2 to get that x has to be greater or equal to 5 halves. Remember, the denominator cannot be 0. That means that 3x plus 15 cannot be 0. So we'll set it equal to 0. Right, move the 15 on the other side. Negative 15, divide by 3, and we get that x is equal to negative 5. Now that's the value of x that makes the denominator 0. So that means that x cannot be negative 5. So x is all reals except negative 5.